So we're going to look at a little bit more of chapter 10. So we start off with an example. Sugar Bomb cereal is including a Sherlock Holmes action figure, which just cracks me up. Sherlock Holmes action figure. I'm like, okay. In each box during a promotion. Claire, it's for those. Yep, it's Claire. Claire plans to purchase boxes until she has all 5 action figures because she is both an avid reader and a sugar fiend. How many boxes should she expect to buy if each figure is equally likely to be in any box?
5 boxes. Gotta think about this one. That's a tricky question.
That would be no. All right. So, I was talking about this just a minute ago. With these, if we just did the numbers 1, 2, 3, 4, and 5, we would have to ignore a whole lot of digits, right?
Yeah.
And so I usually set it up so that I don't have to ignore any of them.
Okay.
So assign the individual digits
It's one word, guys. Assign.
I'm writing it down.
It's a little fast click.
in the table as follows. I'm going to let 0 and 1 be figure A. 2 and 3 be figure B. 4 and 5 correspond to figure C. 6 and 7 correspond to figure D. And 8 and 9 correspond to figure E. Continue looking at the numbers until all 5 figures have been assigned. Or I should say all 5 figures have been selected.
Okay.
And report how many boxes were purchased. Yeah,
Why couldn't you just do through 5 and then,
and ignore all the other ones?
yeah.
You could. The only problem with that is that with, and this is one of the drawbacks of a table like this, you're supposed to do 5 trials. If you're ignoring half the numbers, you may not have enough digits to do all 5 trials.
What do you mean?
Well, okay, so if I'm ignoring 7, I'm ignoring 8, I'm ignoring 9, I'm ignoring 9, I'm ignoring 0, I'm ignoring 7, right? I'm supposed to count until I figure out how many boxes she bought on the first trial because I'm ignoring half of the numbers that are up there, I may not have enough digits available to me to get all 5 trials done.
Okay.
That makes sense?
Yeah. But what if your random number generator was just 1 through 5?
Well, that's
If
the
you just
that's the
did a-
problem with random tables. They're never 1 through 5.
Oh.
The tables are always 0 through 9.
Okay.
Yes.
Oh, why did we have to start at 0? Because wouldn't 0 mean like no boxes were bought, right?
No, what I'm doing is I'm going to look at this number. This number is going to tell me which action figure I got when I bought that box. And then I'm going to keep track of which action figures I've gotten until I've gotten all 5 action figures. And then I'll count how many boxes I had to buy to get that. So like on this one, 7, that's figure D, right? 3 is figure B. 1 is figure A, and at this point you're like, oh, maybe it'll only take 5 boxes. 8 is figure E. And 4 is figure C. Look at that. It only took 5 boxes.
Well. Who was right?
Do you think that'll ever happen again?
Please.
Probably not. All right, so for this one, 9 is figure E. 5 is which one? C? 9 is E again. 0 is A. 7 is D. 0 is A again. 5 is C again. 1 is A again. 7 is D. I've already gotten that one. 9 is E. I've already gotten that one. What am I looking for? B?
Yes.
It's the 2 with it.
So 5 is C. 1 is A. 0 is A. And then finally, so it took us 15 of those. So definitely not going to take 5 every time.
But there is a world.
So there is a world.
You only have
No.
to buy 5.
It can happen, sure.
There is a world.
Yes.
All right, so we've done 2 trials.
If I was a CEO company, I just have 1 box or 1 figure
You
never
were-
show
you
up.
were
Then they
evil.
buy them forever.
You were evil.
Trying to get the last one.
All right, so 8 is figure E. 3 is figure B. Then we get B again.
Now we get to be.
Gonna need it.
And then we get D. And then 4 is C. 5 is also C. 2 is B. We get lots of B's in this one. 9 is E. Are we looking for an A still?
Yeah.
It's gonna be that 0.
7 is D. Okay,
So
so that took us 11.
I agree.
All right, so let's see. 7 is D. 7 is D again. 6 is also D.
Whoa.
That's E. E.
Whoa.
E. So we got 3 D's and 3 E's. Then we get some more, another D and another E. 2 was B. 7 is D again. 8 is E. Now we're only looking for A, I think.
Oh yeah, just keep going. Just wait.
So B, D, C, E, B, C, E, D. Wow.
Yeah, all the way up until that one.
All the way up to the 1?
Yeah.
All right, well, let's save ourselves some time. Let's see, that's 5, 10, 15, 20, 25.
I think it's 28.
You think it's what?
Oh, wait, sorry, never mind.
Okay.
Do we include the?
We started here.
Okay.
Wouldn't that be
Wouldn't that be?
28?
Yeah.
Oh, thank you, 28.
Well, I got scared, guys. I got scared.
I could have
Whatever.
scared of you, bro.
28.
Yeah, usually.
One more trial. Let's see, 6 is D. 0 is A. 7 is D. 2 is B. 3 is B. 0 is A. 3 is B. 5 is C. Are we what are we looking for?
39.
We're looking for E, which is coming up.
Yes.
So that's what, 10? And Jackson, this shows that if just looking at this, I had to use more than the top row. If I was skipping half the numbers, I wouldn't have had enough to do 5 trials.
Okay, that makes sense.
Okay. So, a couple of things to think about before we state a conclusion here. If you were looking at a histogram of this and you did this 1,000 times, okay, what do you think the histogram might look like? What does that mean?
Pretty uniform.
No, it would not be uniform.
Dang it.
Absolutely not be uniform.
Random.
Yeah, just say some statistics words. It's fine.
It's gotta be one. Jackson, can you hold it? Wait, what was that?
So there's going to be some number that comes up more than others.
10.
Sort of the ideal. I don't know what it is.
Oh, okay.
Yeah, you don't know what it is either.
I'm getting pretty close.
What's going to happen way out to the right?
Maybe less than
Infinite.
And there's going to be less and less. Could it be a really long tail?
Yeah, it could go on.
Yeah, you could have a really long tail and you might have some quite large gaps.
Yeah.
Okay. I mean, it's possible on this you could get one where it took them 40 boxes before they got all 5. There is a world.
There's a world where it never stopped.
No,
Wait, what?
no.
Never?
It's not possible.
Eventually, it'll happen.
Do you believe like in infinity in math? Do you believe in infinity?
I don't know. Since I teach calculus, I wonder if that's something that I should look into.
There's a world where it just keeps going.
There's
So what would happen
I
is
think there is.
you would have something at 5, and then maybe 6 is more often, or 7, and I don't know. But eventually, it would tail off, and there'd be this rather long tail out this direction, probably with some gaps, the occasional outlier, all that kind of stuff.
Could we have one at 1 million? There's a world.
It's pretty unlikely.
But
There's
Possible.
okay, good.
but not infinity.
I will keep that in mind.
So after you get past the optimal, it's going to go down and be really tiny, and then, maybe some gaps, and it's definitely going to be right skewed. Part of why it's right skewed is, well, what's the least you can have? 5. Right? Is there an upper limit on how many it could have? No, there's not an upper limit. But if you did it 1,000 times, you're not going to get infinity as one of those times.
But there's no limit. I will not be taking calculus.
You believe
I will not be taking
All right.
Are you taking calculations?
No, I will not be.
So let's find the average number of boxes. So 5 plus 15 plus 11 plus 28 plus 10 divided by 5. So that's 20, 30, 40, 59 over 5 is 11.8?
I got
In your
13.
13.8? Oh, is it 69, not 59? Thank you.
That was good. That was the two, right? I can't do that. I can slip the numbers.
So, from our 5 trials, we found she would need to open an average of 13.8 boxes. Now, am I confident that 13.8 is sort of the optimal number? No. Why? Because I only did 5 trials.
That's what I was about to ask.
Yeah.
Like, wouldn't this not be, like, this could be super far from the average? 'Cause there's
Oh, it absolutely could be. Right? Which is why this is the kind of thing where you program something to do it so that it can do it do 1,000 trials, and you're like, oh, okay, and you can see what it looks like.
Yeah. Maybe Shepard's right. Every single one should be 5. We just got some outliers.
Yes.
Maybe this is the
1,000,000 boxes, Mr. Davis.
All right. So consider the following scenario. A friend hands you a coin and tells you that it's biased towards usually landing on heads. Would 3 heads in a row convince you that the coin was truly biased?
No.
Anyone?
Well, if I was betting on tails, then yes.
Because it's all about you, right?
Yeah.
Yes.
So, probably not. What if you got 7 heads out of 10? Notice it didn't say in a row, it just said 7 out of 10.
No.
Maybe.
Just like when Claire smelled the yes or no.
Yeah, she was freakily good at that, wasn't she?
Yes, I would trust her.
All right. So, this one is for everyone to decide on their own. Let's say that we flip a coin 100 times. Which of the following would convince you that the coin is biased? In other words, pick the least number that would convince you that the coin was biased if we flipped it 100 times. Even if you flip 95 heads out of 100, you don't think it's biased.
No, it's a coin.
You can weight coins, you know.
You'd be easy to fool.
100 times. Let me see this way.
So everybody think about that for a moment.
To convince me.
Yeah, to convince you. All right. So, he didn't circle anything till after he turned around and looked at Jackson and went, "Me too."
I made a decision in my mind.
All right. Is there anyone who needs 95?
Again, that's this guy.
You need 95?
Yeah.
And then I Shepard does too.
Okay.
It's like
Wow.
wrong. You know, we're
Tough
wrong.
room. How about 80?
Put your hands up.
You voted for 95.
I forgot that I started thinking 75.
Okay.
My type of logic, bro. What do you say?
70?
70?
60?
54.
54? Wait a minute, I've said them all.
Tony doesn't believe in any of
Tony thinks this
Oh, you
is
said
like
95?
biased.
Tony, how would you say?
70?
70?
Yeah, Tony needs 100.
I'd probably only need 60.
60, 70.
Me as well, Mr.
All right, well, let's do this.
Stop looking at my-
Grab your computers. Do a web search for simulate 100 coin flips and choose the one from Calculator Soup. What did I say to look at? Simulate 100 coin flips.
How's it going? The Wi-Fi, Mr. Davis.
What about it?
It's really
It's
bad.
gone. It's gone. It's gone. It was never here.
I'm already there.
Gone, but never. Oh, well, might I have the faculty password?
Is the student password being dumb?
No,
Or is it operator error?
Don't say that. Don't say that, Mr. Davis.
That.
Calculator Soup. I like the name of that website. It's very.
Goes on in your head, so stuff.
Yes, that is me when I look at my.
Oh, I got
calculator.
50-50.
That is.
All
my
right,
quizzes.
so flip it 100 times. And then on the table, fill in what they got for heads and for tails. It was 52% and 48 on mine. Yours should be different.
Oh, dang it, why don't I do it? Flip all 100. Whoa.
Mr. Davis, you wouldn't like my coins.
Pardon?
You wouldn't like my coins.
I wouldn't like your coins.
No.
Why?
You said 60 is what it would take, right?
Yeah, what'd you get?
61.
Ooh.
The trial 10.
41, 50 minus the previous one.
Ooh, my 10th one was my closest one to that.
I got a 62% flipping after that. Trials.
Whoa. I haven't seen 60.
59, 41.
Keep on flipping, guys.
I just got a 61 and a 60.
Keep adding. Keep adding.
Is there some bullshit?
Yeah.
Try to hit a lucky number.
Dude. I don't want 50-50.
All right. So, in looking at your numbers, and so you said you had two where one of them was greater than 60?
Yeah, like 3 flipping after.
You had three that were greater than 60?
Got 61 and then 62 twice.
Anyone else get any that are bigger than 60?
I got 60 2 times.
Okay.
I got 62.
All right. Anyone get something bigger than 65? So you don't really need 95.
Yeah.
You don't even need 80.
Yes, no,
You might could make a case for 70, but if you just did it once, how often does it happen that there turned out to be 60 or more?
Not often.
You know, between all of us here, that's what, 8, 9. So that out of 90 trials, probably 6 or 7 times that happened, less than 10% of the time. So can it happen? Yeah. Is it likely to happen? No. So we'll talk more later about what a convincing number is. On this one, 70 probably is. Now, if you had flipped the coin 10 times and you got 8 heads and 2 tails, are you convinced that it's weighted? Probably not. But if you do it 100 times and you got 80% heads and 20% tails, you're probably convinced, right? So what if you ran your simulation 10,000 times? Do you think that would all be close, that generally be closer to 50?
Yes.
Do you think you'd even get any that were 60% one way or the other?
Probably not.
Probably not. Okay, we'll talk more about this as we go. All right, let's go on to the back. Suppose that a basketball player has an 80% free throw success rate. Design a random number simulation to find the number of free throws we might expect for them to make in a row. Okay. With percentages, it's almost always easiest to just use a random number generator that generates a number between 1 and 100. Okay? So, use a random number generator. To get a series of numbers from 1 to 100. Let 1 through 80 represent a success. And 81 to 100 represent a failure. So that's the component, right? You're going to have either a success or a failure on each one. For the trial, what are we going to do?
Generate the random numbers and continue doing it until you generate a failure.
Okay, so for the trial,
1 through 8.
we will count the number of successes until we get a failure. Yes.
What if you start with a failure?
Then you had 0 successes. Yeah, that's a great question. Yeah, they can miss their first free throw.
Good question.
So the response variable here will be the number of successful free throws in a row. And on this, like we would do for most of these, what we would report would probably be, after many trials, report the average of the response variable. Okay, so on that one, you're waiting until something bad happens, and then you stop and count how many you have until that, and you start again. This next one, a little bit different. Using a basketball player that has a 72% success rate on free throws, design a random number generator simulation to find the number of shots they might make out of 5 chances at the end of a game. Now, we're not going until they make 5, right? We're giving them 5 chances. So our component is very much like it was on the last one. Generate random numbers from 1 to 100. Let 1 through 72 represent success. And 73 to 100 represent failure.
Run 5 trials.
Well, not 5 trials. You're going to run the component 5 times. So take 5 random numbers and count the number of successes. The response variable then would be the number of successes. After 5 shots. And again, for the statistic, we would probably do, after many trials.
Maybe after
Pardon?
After 5 trials, or still many.
I'm not doing 5 trials.
Oh,
Nowhere in this does it say do 5 trials. right? The trial is the whole thing. The component is each individual shot. It takes a while to get used to that. After many trials, give the average of the response variable. By the way, on this one, if you did enough, what do you think the average number would be?
Like 3.6 or something.
It'd be exactly 3.6 because that's 72% of 5. If they really are a 72% free throw shooter, we would expect that it's 3.6.
So if you did 100 trials, your statistic, like the average, would be 3.6.
It'd be pretty close. I'm not saying that it would be exactly 3.6, but if you did 10,000 trials, it really should be awfully close to 3.6.
But maybe in Shepherd's world,
There's at least one.
All right. Now, how would our trial response variable and statistic change if we want to know our players' chances of hitting both shots when they go to the line to shoot 2? All right. So it's still this component. We're still generating random numbers from 1 to 100, where 1 through 72 is a success and 73 to 100 represent failures. Okay, how would the trial change?
Generate 2 numbers each time.
Yeah, we would generate 2 numbers. And record each as a success or failure. Count the number of successes. Right, that would be 1 trial. So the response variable would just be the number of successes after 2 shots. Oh, wait a minute. I didn't read this carefully. Did you?
It should be.
What now?
Should be like if you make both, that
Yeah.
becomes 1.
We want to know his probability of making both shots. Oh.
So it only is a success if both numbers are a make.
So if both are successes, the trial is a success. So our response variable, well, I should get an eraser at this point. The response variable here is just going to be either success or failure for each trial. And since they want to know our players' chances, we probably would want to report as our statistic the percent of trials that were successful.
So on this one, would you expect the player to make both 72% of the time?
No,
It would be less.
it's right, because his first shot he's going to make 72% of those, and his second shot he's going to make 72% of those. The way you find that probability is multiplying those two together. It'd be 0.72 times 0.72. You would only expect him to make both of them about half the time. It's a little bit like it's counterintuitive, but let's say that you have this monster of an NFL team, and they're a 90% chance of winning each individual game. Their odds of going undefeated in a 17-game season is way lower than 90%.
Yeah, because you'd have to do 90% times.
You'd have to do 90%, 90%.
Times itself 17 times.
Yes.
Uh,
Yeah, it's not that's why it's so unlikely.
yeah.
Even if you're the best team, it's hard to get that to happen every time. All right. So how would our trial, response variable, and statistic change if we want to know our players' score when they go to the line to shoot a 1-and-1? So on this one, they have to make the first one in order to get the second one. Yeah.
Does it want to know the success rate of it making the one and the second one in? Or
Yeah.
just,
Yeah. So for our trial, we'll have to look at if the first number and the second number are successes, we'll record their score recorded too. If the first number is a success, but the second is a failure, what are we going to record then? Right. And if the first one's a failure, well, that's it. So I'm just going to put otherwise record 0. Here our response variable would be the number of points that he scored. And once we've run many trials, what will we probably want to report?
Their average score.
Yeah. After many trials, report the average score. That's a lot harder to figure out. And these are all things that we're going to learn about. Okay, but right now you're just learning kind of how to simulate them. Okay. Well, it's quiz time. Everybody's